Hello everybody, I would like to code something really simple in Python today that is going to be a small encryption program, extremely simple, and I would like to use this as an opportunity to sharpen my own Python skills. So let's just jump right in and create a new directory in my projects directory and call that Cipher, because that is the encryption method that we're using. And let's create an encrypt file. Oh no, let's call it caesar.py. And in here we are going to do the following. We are asking the user for an input. Enter your secret. Let's save that and see what happens if we execute that file with Python. And there's a prompt, enter your secret. And now we can type something, for example, hello world, and nothing happens after that. So let's just open the Python shell and call the input method there just to see what it returns. Enter your secret. Now I'm prompted. I type hello world and the return value of that method is hello world. Okay, so whatever the user inputs, that is written into a variable. So if we create a variable that is called message and we say message equals input, enter your secret, then I enter something, this is my secret. And if I now query the value of message, then it contains this is my secret. So let's exit the Python shell again and open the Caesar cipher. And that's what we're going to do here. Message equals input, enter your secret. Let me just also add a space at the end of that call so that it looks nicer. Now we have a message and we want to encrypt the message. Let me just write some comment here. Get message from user. And let's try to encrypt the message, but to encrypt it, we have to get an encryption key. And the encryption key will also be entered by the user. Get encryption key from user. And the key is also passed in via input. Enter your encryption key. And then the user can enter an encryption key. And to understand what the user is supposed to enter, we have to look at what we're even implementing. So let's just make all of that black so it's easier to look at. The encryption method basically looks like this. The alphabet is composed of letters A, B, C, D, etc., etc. And each letter is assigned with a new one. But to keep it simple, we assign those letters based on alphabetic order. So let's say the encryption key is, let's say it is 2. Let's say it is 2. That would mean that here in the associated secret alphabet, the alphabet would start with a C. So C, D, E, F, etc. So that is the encryption key 2. And effectively that means the encryption key determines how much the target alphabet is shifted. And this way, when we write a message, for example, secret, we check every letter individually, for example here the S, and then we think which letter comes 2 letters after the S. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T is the first after that. U is the second after that. So that would be encoded to a U. Then the E would be encoded to E, F, G for the encryption key 2. Let me just write key is 2. The C, no, we also know that this E will also be encrypted to G, of course. This C will encrypt to C, D, E. And the R will encrypt to A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, R. Oh, wait, let me just hide the taskbar. That's annoying. Q, R, S, T. Okay. T. And then the T would encrypt to A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V. Okay, very simple. So that is the encrypted message right here. And that is the encrypted secret. Very simple. And to decrypt that secret, all we have to do is shift the letters back by the key that we used for encoding. Okay, it's incredibly simple. So we know that the key is a number. Type is number, and for the message, the type is a string. All right, now what do we do next? We have to iterate over the contents of the message probably and get each letter. So if we do for each letter in message, I think we should be able to print every individual letter. Let's see if that works. Let's just print all the letters individually. Let's go over to this console here, clear, go into the Caesar Cipher directory and execute Python 3 Caesar. My secret is hello. My key is 2. And yes, each letter is printed individually, which is good. So that means that this loop is working. We could print something like encrypting letter and then enter the letter here, although that is probably a bit too much, but let's keep it for now, just for understanding the code. Then for each letter in message, find the encrypted letter, find encrypted letter, and the encrypted letter is basically just encrypted letter is just a letter plus somehow the key incremented. But now the problem is that the letter is a string, it's a character, and the key is a number. So how do we determine which letter the encrypted letter should be? One simple idea would be to have a variable that's called alphabet, and that contains all the letters in order: A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. So that's the entire alphabet. I hope I didn't mistype somewhere, but that should be correct. And then we can do the following. Let me just delete that. We have to determine which position in the alphabet our current letter is in. So we do alphabet.find or alphabet to lowercase maybe. Let's just try to lowercase. I don't know if that works. There should be a function that does that in Python. Let's try that. A, B, C, D, E to lowercase. Yeah, that doesn't work. So let's look up how to lowercase something in Python. Yeah, okay. Okay, give me a second. There's the browser. To lowercase Python. String.lower in pandas. But that is a library. I don't want to use a library. Okay, no, it seems to be built in. String.lower. Return a copy of the string with all the cased characters converted to lowercase. Maybe one issue could be if we have a message and we want to encrypt that somehow, we want to encrypt the message, then the first letter is uppercase. And of course, I want to keep that uppercase in the encrypted method such that when it is restored and decrypted again, that we still retain the information of the uppercase letter. That would be very useful. How do we do that? We need to check for each letter whether it's uppercase, I think. Find the encrypted letters. Okay, so let me just what do we do? Okay, let's get the letter dot upper. Let's make the letter that we are scanning right now, that we're iterating over, uppercase. Then we can check if the alphabet, or if that uppercase letter is in the alphabet, because the alphabet is only uppercase letters. In alphabet, if the letter is in the alphabet, then let's do alphabet.find letter.upper. Or we could probably do it even simpler. No, let's do it like that. And that find method returns the index of the letter in the alphabet. Now, to encrypt it, to encrypt that letter, we do the following. We increase the index by the key that we provide. So, for example, for the letter C, we would find out this is the index 2. Index starts with 0, 0, 1, 2. And then if we say the key is 3, then that would add 1, 2, 3 on top of that index. And if we retrieve the letter at this position from the alphabet, then that is the encrypted letter. Okay, that means we have to increment the index by the key and create a new variable, encrypted index. And then we retrieve the alphabet letter at the encrypted index. And that is the encrypted letter. And that should be working. Although there is an edge case, say you encrypt one of the letters back here X, Y, or Z. And let's say that index is 25 or 26, I don't know, 25, I think. And now you add the key 8. Now you would go beyond the alphabet, which doesn't work, of course. You want to wrap around and start counting again at the beginning of the alphabet. And to do that, you need to do the following. You need to modulo by 26 the length of the alphabet, or even simpler, if we don't want to think of that, by the length of the alphabet. I think this should work. Okay. And now we have an encrypted letter and an encrypted letter. And then the encrypted message that we start creating up here. Encrypted message is an empty string at the beginning of the encryption, obviously. But at the end of the encryption, down here, we add the letter that we just encrypted. And then what do? We print the encrypted message. Print encrypted message. And let's also print, for user friendliness, encryption successful. Here's your encrypted message. Now this program doesn't yet fully work, but let me show you what happens. Let's execute the application and see what happens. I will enter my secret hello, and my encryption key is 3. Now, first of all, we get an exception. Okay, that is because we are not considering that the key is a number. And here the code is still thinking, or the Python runtime is thinking, that this is a string. And that's why it complains that this integer here and the string cannot be added using a addition operation, which obviously is the case. But we need to make this a number. Enter your encryption key, and let's hint that it is between 0 and 26. Okay, let's try again. My secret is hello, and that still doesn't work. Great. Why does this not work? Okay, let me just pull up the web browser again. Python string to number or integer. Maybe I have to say int instead of number. Okay, int. Let's try again. My secret is hello. My encryption key is 5. And there's still an issue. The encrypted message cannot be concatenated with the encrypted letter. Why is that the case? It again says bad operand type for unary plus string. Where is that happening? It's happening in line, It's happening in line 23. So let me just enable line numbers. And let's go to line 23. It's this line right here. The encrypted message is extended by the letter, which I would have expected that this works in Python, because we can just, let me show you why I think that it works. I can just say hello and then plus string, and this would concatenate both of those strings. And I would think that, or I thought that encrypted message is a string and encrypted letter is a string as well. Now that doesn't seem to be the case, otherwise we wouldn't get this error. Possibly the alphabet at encrypted index doesn't return a string. Oh no, I know what the issue is. I mixed up the order here. We have to use plus equals to increment by the encrypted letter instead of equals plus. So this was a beginner's mistake, or a typo rather. So let's execute the application again, enter my secret, hello, my encryption key is 8, and the letters are individually encrypted, and the encryption is successful, and this is the encrypted text. Now, as you can see, because we retrieved the letters from the alphabet, which is only uppercase, the encrypted text is also only uppercase, but I don't want that. It should be alternating between upper and lowercase depending on what is input into the string, into the message. Okay, let's have a look at how to do that. We have to check if the letter is uppercase or lowercase. And there's probably a method for that. Python check if uppercase is upper. There's an is upper method. There's a method for everything in Python, which I really appreciate. Okay. Then let's check where we have to make that change. First of all, we do check. No, here we get the encrypted letter. And here we have to check if the input letter, if the letter is uppercase, if is upper, then we just extend the message with the encrypted letter, which is already uppercase, else we make it lowercase. Encrypted message extended by the encrypted letter, and then lower. And that should retain the capitalization information. Let's try to execute that. And as you can see now, the encrypted message retains that capitalization information. All right, that is the Cipher text implementation. Let's remove the individual letter encryption printout, and let's also add something very useful, and that is a library that is called what was the name? Something to copy the message directly to the clipboard. Python copy to clipboard. Paperclip. Yes, paperclip. Paperclip. Let me show you how that works. Okay, so paperclip is a library that basically can copy whatever string you want to your clipboard. Okay, so for example, if I do copy paste manually, it is now inputting what I just copied manually. Or wait, let me just create a new message here. I like zebras, but I don't. I like zebras. That's okay. And that is the encrypted message. Oh, as you can see, we have a bug. But let's ignore that bug. We are missing spaces and special characters. We have to handle that as well. But let's just assume that's the program that we're executing. Now I would have to copy that manually and paste it wherever I need it. It would be useful to use a library, paperclip, and then we can call paperclip.copy to copy the result of the encryption directly into the clipboard. Encrypted message, just like this. So that is the last statement here. And let me just also print encrypted message, or no, copying encrypted message to clipboard. And then after that, let's print done. All right, let's try to, I don't have a module named piperclip. Let's do pip install or pip 3 point whatever, pip 3 install piperclip. Let's hope that works. I don't know. And let's try to execute that. Now my secret is hello. Hello world. Encryption key is this. And now let's try to paste something. And as you can see, I pasted the encrypted message from here directly to my terminal. Let's try again. So my secret is now, I don't like fish. And the encryption key is now 15. And then doing a paste operation, it is directly copied to the clipboard, which I find really nice to do things quickly. Okay, but that is just playing around. Let's focus on fixing the real issues here. For each letter in the message, we try to encrypt the letter. If that letter is not in the alphabet, we have to add an else case here. Letter is not in alphabet. And in that case, in case it is not in the alphabet, then we just add it to the encrypted message without encrypting it. Just like this. And this should work. Let's see. I don't like fish. I do like fish, by the way, but I just typed that because it has a couple of special characters. And let's try to encrypt that with encryption key 14. And this right here is the encrypted message. Awesome. And it's, of course, directly copied to the clipboard, ready to paste somewhere, wherever you need it. And now, let's just reverse all of that. We have a working encryption routine. Now let's write a decryption routine. Basically, the decryption is the exact same thing as the encryption. And to determine whether we want to encrypt something or decrypt something, let's try to get that information from the user. Ask user whether encryption or decryption should be applied. So the user uses this program to both encrypt messages and to decrypt messages. And then the user can do something like, can enter input, should message, no, encryption 0 or decryption 1. And then the user can simply enter something. Then we get encryption. Let's call it encryption toggle. And that is also an integer or maybe even a Boolean. Let's keep it simple and make it an integer. So we do the following. All we have to do is, when the message is being encrypted, instead of just encrypting or decrypting it, let's try to extend that, find encrypted or decrypted. No, find encrypted letter. Let's make the encryption a method. Define encrypt message. Then all of that is the encryption method. And let's also create a method decrypt message. And it's basically the same thing. So I copy all of that. And for each letter in the encrypted message, which is here called message, and let's change all of that. Encrypted message, and this right here is also an encrypted message now. We check whether the letter is uppercase and it is part of the alphabet. Okay. Then we check the index of the alphabet, and then the decrypted index is the index minus the key. Now we reverse that operation. And then the decrypted letter is the alphabet at the decrypted index. And if the letter is an uppercase letter, then we add it to the decrypted message as it is. And if it's a lowercase letter, we add it to the encrypted message. To the decrypted message, of course. And of course, we add the decrypted letter here. So I'm just adapting the naming to fit our needs. But of course, this is duplication of logic here, but this makes it most clear, I think. So here is the real difference. It's the minus between the index and the key. And then, if the letter is not in the alphabet, then we add it simply to the decrypted message. And at the end of that method, we return the decrypted message. And similarly, at the end of this method up here for the encryption, we return the encrypted message. And that should be it. Let's just add the logic that determines whether we encrypt or decrypt. So the user types type 0 for encryption or 1 for decryption. The user, yeah, we do that down here. So here we check if encryption toggle is equal to 0, then we encrypt. Yeah, okay. If it's equal to 0, then we encrypt the message, encrypt message, and that gives us a result. And down here we print the result. Results, copying results to clipboard. And let's say here operation successful. Here's your results. Okay, now we can if we encrypt the message, we get this result here, and else we get this result because we decrypt. Yeah, and that should be it. Let's just default this to an empty string. And Let's see if that works. There's for sure some bug in the code. Let's see. Let's execute the application and say we want to encrypt something. We want to encrypt the string hello 123 full stop using the encryption key 5. And there's a bug. Name encrypt is not defined. That means that the method cannot be found. Let's check. Yeah, right here this method is attempted to be found somewhere, but it is defined below that logic, so it has to be moved to the top. Okay, so we move the methods, the functions to the top of the file, and only then we will execute all the logic, such that when the code down here is being reached, then it is already aware of the function definitions. So let's try again. We encrypt hello 123. This is my plain text. And then let's encrypt with encryption key 5. And that doesn't work because there's a local variable encrypted message referenced before assignment. Where is it referenced? It's in line 11. So that is this line right here. And that is because we have to first create the message, the encrypted message variable. And we have to do the same down here. But for the decrypted message. And we can delete that down here. Okay, let's try. Encryption or decryption 0. Enter your secret, hello 123. This is my plain text. Encryption key 5. And I have a result copied to the clipboard. Now, since it's copied to the clipboard, let's just try to decrypt it right away. Python 3, Caesar Python. And let's decrypt it here using the 1 flag. And we use the encryption key 5, so we have to use the same key for the decryption as well. Oh, yeah, but now it didn't do anything. Somewhere there's a bug in the logic. What's that bug? Here we try to decrypt the message. Okay, let's scan that method quickly. We have an encrypted message. The decrypted message is not found yet. Then, for each letter in the encrypted message, we try to find if we check whether the letter is in the alphabet. Then we check the index of that letter, if it's in the alphabet. Then we subtract the index with the key here. We might have to use... Wait, if the index is 1, for example, the letter is A, and the key is 5, then this will result in a negative value, and we then... then we will have a negative value here in the decrypted index, which then attempts to access the alphabet at a negative value. But since this is Python, this even should work, I guess. Decrypted letter. Printf. Let's print the decrypted letter. plus string decrypted letter. I think the string is not strictly necessary here. Okay, let's try to decrypt. Didn't I add the secret earlier? Wait, let me remove the print statement again. Let's try it again. Encryption 0. My secret is hello. The key is 5. Now let's try again. Decrypt. My secret is this and the key is 5. Oh, no, the software works. It works. I just used it wrongly. Okay, and that is the encryption and decryption program in Python. Let me just use a more difficult example. Encryption, we encrypt in the following text. Linear algebra is a topic for nerds. Full stop. Are you a nerd? Question mark. Then the encryption key is 15. We get a result. That is the result. Now we try to decrypt that. I enter the secret here and the key was 15. And here's the results text. That means it was successfully decrypted. Awesome. And let's try to decrypt that same message. Let's try to decrypt that same message. Let me just copy it from up here. Using a wrong key, for example 4, and the result is of course not readable. And that means that the cipher that we implemented is working. So again, let me just encrypt something. Please leave a like. And the encryption key is 7. And this has copied a result to the terminal. Now let's decrypt that message. Let's paste the message. And let's say the encryption key was 7. And here's the message decrypted. Awesome. And that is our small little encryption and decryption program in Python that is called the Caesar cipher. I will put a message in the comments and will challenge you to decrypt it. It's not too hard. That is my homework for you. No, it's not really homework, but if you're interested in playing around with it, it's quite simple to break this cipher if you just play around with the code a bit. And I will put an encrypted message into the comments. That will be the first pinned comment. And the first one who cracks it is the king of the video. Okay. If you enjoyed this video, then please leave a like and subscribe, and see you next time. Bye bye.